Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. Let's compute the antiderivative of this given polynomial function. Now this time, we are going to use here the two presented rules. We have the power rule and the constant multiple rule. Before we start, let's not forget that for a power rule, it tells us that the integral of any function, let's say in terms of this form, x to the power of n with respect to x, is identified as x to the power of n plus 1 over n plus 1 and plus your constant c. And previously, we also identified the constant multiple rule, stating that if we have here a certain constant as a multiple of your function with respect to x, we can just simply take out that constant and proceed with the integral of your function here that may use the power rule before multiplying that said constant. So here we have the integral of 2x cubed with respect to x. Using the constant multiple rule, we can take out constant 2 and we will have here x cubed with respect to x. And this time, we're going to use here the power rule, simply not forgetting the factor of 2 outside. You will have your x to the power of 3 plus 1 over 3 plus 1 plus c. Take note, we can of course write it in this manner, but since our c is also an arbitrary constant, you may just simply have it later on as 2c, or just again a general form for c, which is true for any constant. This would become 2 times x to the power of 4 over 4 plus c, or again 2c. Regardless of that, it's still c, as we are going to continue doing this here. 2 over 4 is 1/2. So our final answer here is 1/2 x to the power of 4 plus your c. This is the antiderivative of the given polynomial function here using the first two rules. Allow me to add another example here just to continue with the understanding of this item. Let's have here, we have here 3t to the power of 7. Okay, with respect to t, of course that's very important. So we are going to take out the 3 integral of t to the power of 7 with respect to t. So again, you have here 3, you have t to the power of 8 or 7 plus 1 over 8 plus your c. Okay, I just automatically use n plus 1 here. So you have your final answer of 3/8 t to the power of 8 plus c, or 3c. But then again, if we're going to have here 3c, we can still write it as any arbitrary constant c, so it's just as it is. Of course, you can try to derive this together with this result earlier. If the result for a derivative of that would return to this function here, and if this would return to this function here, that means your answer is correct. Thank you very much for watching. So what are you waiting for? Subscribe now!